Good afternoon. So we will continue discussing the inheritance. Last time we discussed the abstract class. We mentioned that sometimes when we design Java applications, we need to create an abstract class. Abstract class is different from interface, but it has the same property as the interface. We cannot create object from the abstract class. We cannot create object from interface. But the thing that here is abstract class will be part of the Java hierarchy, and it will contain some fields, some methods that is not implemented. At least one abstract method inside the class will make this an abstract class. Using the keyword abstract inside the header of the class, public abstract class, that will make the Java recognize this as an abstract class, and you cannot create an object. Abstract class contains constructors, and if you extend the abstract class, you can call these constructors from the subclass. Java interface, we revisit the Java interface, and we saw the relations now with the Java interface and the inheritance hierarchy. We can create the Java interface that contains public abstract methods, and we can ask independent classes to implement this interface. So some independent classes, they can implement the same interface. And we mentioned that in the Java support single parent or single subclass. So inheritance, you can extend only one class. But in the Java, you can implement as many as you want interfaces, okay? And we close with discussing the polymorphisms, and today we'll continue discussing polymorphisms. Okay, a lot of questions last time at the end of the lectures. Many of the students approached me with some questions wondering what is the polymorphism and how the polymorphism is working. We're going to start today by highlighting the polymorphism again, and we will see design by contract and the relation with the inheritance. We will see the static fields. We already visit the static field on the previous lectures, and we define static fields, and we say when we define a static field or a static method, that means there is only one copy of these fields or one copy of these methods. Okay, and we're going to see today the relation between the static field and inheritance and the static method and inheritance. Starting from polymorphism, from the point that we closed last time, the polymorphism is the ability to use the same behavior. When we say the behavior, okay, in these lectures or the next lectures or the previous lectures, we mean by the behavior a method. So if we use the same behaviors, that means the same set of methods, okay, for the object, but of different types, okay. That's using the polymorphisms is another one of the greatest Java capability that allow us to create the same code, okay, that is deal with the generic type, general type of the object without need to be more specific about the type. So here is an example. We discussed this example last time. We revisit this example again to make it clear for everyone. And you can see here, we have the Java hierarchy. We have the person, and we have employee, that subclass from the person, and manager is a subclass of employee. And look at the person. Person has three methods, or you can say three behaviors. That can get names, get address, get phone numbers. Now we extend the behavior, we extend the class of the person by creating a subclass called employee. And inside this subclass of employee, we added two new behaviors, two new methods. That is get employee numbers and get hourly pay. So now the employee actually is a subclass from the person. It has also the three methods that are exist on the person, which is get name. You can ask the employee to get a name. You can ask the employee to get an address. You can ask employee to get a phone numbers. Now, the customer is also a subclass from the person. We have two additional methods added to the customer, where they are get item purchase and get purchase history. But still, we can ask the customer, because the customer is a subclass from the person, we can ask the customer to get a name, to get an address, and to get a phone number, because the customer is a subclass from the person. And also we have the manager, which is extend the employee, okay? And we get duty and get subordinates, which is the two additional methods that are defined inside the managers. Now, we can do typecastings of single, you have single employee objects and then typecasting to persons. You can see here in this example, the client decided to define one method to print, okay, and need to print an object. And you can see inside the argument, public void print, what is the type of the parameter is a person, okay, declaration type of the person. And it's receive an argument as a person, and then print p.toString. Now, later on, he defined 4 variables, p1, e1, m1. Now, p1 has a declaration type of a person, create a new object of person. And e1 has a declaration type of a person, and create a new employee. And M1 has a declaration type of a person too, and assign new managers. You can see here, we can use the inheritance because the person is a superclass for an employee. A person is a superclass of a manager. So you can use the person as a declaration type and create object from the manager and assign it to the person. Then you are using this .print. You call the method that you define on the top to print. So you send P1, E1, and M1. So once you are inside the method P.toString, it will recognize that P1 is pointing to the object of type person. It will ask person.toString. And if you send E1, we recognize that the object type is employee. We're going to print employee.toString and manager.toString. So here is the most important thing is to notice that all these P1, E1, M1 have the same declaration type. And we call the declaration type, one in the left side, is a declaration type of type person. So we create only one method. We don't need to create public void print and give as an employee as an argument to call employee.toString. Okay? Now, we can change also to an object. Still, this is work. We discussed this last time because object is a superclass of all the classes that we create in our Java applications. So we send the P1, E1, M1 to the print method, and this Java will do the automatic object casting for us. So still, we're going to recognize that we have a person type. We're going to print person.toString, employee.toString, and manager.toString. Now, this method, the behavior of the print, is a polymorphic. So this method is a polymorphic because it's the same method. We use it with different type. Okay? Still, we are sending the different types, but still we are able to recognize and print person.toString, employee.toString, because we create an object from the person and we assign it to P1, where P1 has a declaration type of person. Now, if person, P1 has a declaration type of person, what is the actual type? The actual type for P1 is a person. What's the actual type for E1? Employee, which is the runtime. Okay? So we have to always, when we work now with the polymorphisms, with inheritance, we have to recognize two things: the declaration type and the actual type. The actual type that we are using a new person, a new employee, new managers. So for M1, what is the declaration type? Is a person. What is the actual type or a runtime type? Is managers. Now, just to, I told you last time about, you can imagine you have the employee. So you can access outside, any person from outside the client can access the employee by calling one of these public behavior or public methods. Get employee numbers, get hourly pay, get address, get phone numbers, get name. Now, get address, get phone numbers, get name, those are actually is defined on the person. So when you do the casting, I told you last time, imagine you take this object and you put it inside the sphere or inside the shield, but now you can access this through only 3. You restrict the access. I didn't change the employee. It's still get employee numbers there. It's still get hourly pay. It's there. I didn't change. I told you. Typecasting of object inside Java, we're not changing the object. We just restrict the access. So now we restrict the access to the employee object, which is inside this sphere or inside this circles, by only accessing, allow to us to access only get name, get phone numbers, and get address. Okay? If you understand this, you will understand the polymorphism. So what is the actual type? What is the declaration type? What is the runtime? What is the declaration type? You understand that when you do the polymorphisms, sometimes Java did it automatically for you, or you can do it in your code in purpose. But whenever you do casting for object, you're not changing the object. You just restrict the object. You just restrict the object. We're not changing the employee. Still, we can access get employee number. It's still there. But now, when I do the casting to the person, I cannot access it from outside. I can do this by remove the casting so I can access it back. If I do the casting, the only now restricted access to these 3 methods. Any question? Okay. So having all this, we now introduce 2 new terms, which is the late binding and dynamic bindings. Late bindings is at the runtime, we know which type of method we have to call. Because now the process of polymorphism add more complicated issue to the compiler. The compiler will not know at which time I should call this method or this method, employee to string or manager to string. I have to look at the actual time of the variable to determine I'm going to call employee.toString or manager.toString. That is what we call a late bindings. So that means a polymorphism is the ability to associate many meanings to one method name. But there's one restriction here. Polymorphism work fine with everything except private, final, and static. Keep this in your mind. Late binding polymorphisms is work fine with everything except private. Because the private, no one can access from outside. So there is no point of late binding. You define it, it's only defined. Final, it's only one copy. No one can change it. So what's the meaning of late binding or something like that? Static is only one copy also. You cannot change it at runtime. Okay? You can call it even without an object. So there is no point of having late binding with private or final or statics. Dynamic dispatch, we look at the actual type of the object, then we decide which definition we're going to call. Here we have a person as a declaration type. We define a variable called vPersons and equal a new employee, and we give a name for this employee. So the person is as an actual type, a new employee as a run type. Okay? Now if you have toString is defined inside the person, you override it inside the employee. Now if you call vPerson.toString, which one you're going to call? Wrong. We're not going to call person.toString. Why? Based on our polymorphisms, we're going to look at the actual type. What's the actual type? Employee. So we're going to call employee.toString. We're not going to call person. If you answer person.toString, you're going to have a wrong answer. So polymorphisms allow us for what we call late binding and dynamic dispatch. We look at the actual type, okay? Actual type is employee, okay? We go to the actual type and we're going to call toString or from the employee, not from the declaration type, not from person.toString. Okay? If you understand this, you will find the polymorphisms easy to understand and you can use it later on. Now, remember that if you have typecasting, so you can do typecasting to the superclass. I can do typecasting from manager object to an employee. I can do employee to a person because person is a superclass of the employee. Employee is a superclass of a manager. I can do casting to an interface. If this class implement this interface, I can do typecasting to the interface. Or I can go back to the original because typecasting of object, we're not changing the object. We just restrict the behavior. So I can do typecasting for the superclass. I can do typecasting for the interface. I can do typecasting back again to the original objects. The actual type or the runtime determine which method we're going to call. Here, for example, we have object, person, employee, manager, customer, company, cars. All these class, okay, they implement insurable interface. So we can do typecasting between the employee to the insurable. Can we do that? Employee to insurable, person to insurables, customer to insurables, company to insurables, car to insurables. If the class implement this interface, you can do typecasting to that interface. If the class doesn't implement this interface, you cannot do. You can do to the superclass. Okay? Here, for example, employee, we can do the typecasting of employee to an employee, to a person, to an object, or insurables. Okay? If you are trying to do typecasting to a managers, or a customer, or a company, or a car, you will get class casting exception. You cannot do the employee typecasting to our customers across the hierarchy. You can do it in the top of the hierarchy. You cannot do it to a company or to the car. Okay? Now, automatic typecasting. When the Java do the automatic typecasting? In this example, you can see we define vPerson and vEmployee as declaration type, person and employee, respectively. And we have vEmployee and we create a new employee. So vEmployee has a declaration type of employee, match the actual type. So now, if I assign vEmployee to vPerson, Java will do the automatic casting for me. Okay? If you have such kind of code in your application, Java will do the automatic casting for you. The other place where the Java gonna do the automatic casting for us. Here we have vEmployee and we create a new employee. So the declaration type of the vEmployee and the new employee match. So the declaration type is employee and the actual type is an employee. Now we have a method. We define a method called public void do a standard hiring process, but the argument inside it is a person. And then we send vEmployee, which has a declaration type and the actual type as an employee, to this method. Once the vEmployee enter this method, Java will do the automatic casting for us. So if you have such kind of code in your applications, you will have the automatic casting. So the employee will be automatically cast to the person inside this method. Now, you have this hierarchy. As an example, you have the circle, triangle, and rectangles. Now, these are all shapes. We define a shape S. S has a declaration type of shape. C, T, and R both have declaration type of circle and a new circle. So the declaration type for C is matched with the runtime, and also for T and R. We can do this. We can assign C to S, T to S, R to S. All this we can do because shape is a parent for the circle and triangle and rectangle. And automatic casting will be taking place here. Now imagine that you have a method that draw the circle, a method will draw the triangle, a method that draw rectangles. So you will have such kind of code. So you have a separate methods inside each class. So I have a specific method to draw a circle, a specific method to draw a rectangle, because drawing a rectangle is totally different from drawing circle. And drawing a triangle is totally different from drawing a circle. But we have such kind of Java inheritance that the circle extend the shape, triangle extend the shape, and rectangle extend the shape. We can use such kind of inheritance relation to do the polymorphisms. If we do it without polymorphisms, we have to ask if S, the shape, is an instance of the class of a circle, and then so we can call s.draw the circle. We have to check the object before we ask to draw, because drawing a circle is different from drawing a triangle or drawing a rectangle. So we have to make sure that we are handling a type of rectangle to draw a rectangle. Now with the polymorphisms, we can do this only with one code, s.draw, because the actual type will determine which draw method we're going to call. It's the same as toString with the employee and the managers. Okay? So with the polymorphisms, so we can remove all this if it's an instance of a circle, or if it's an instance of a triangle, or if it's an instance of rectangles, to make sure that we are calling the right method. Now we just call s.draw, which is actually going to define that which draw method, because we're going to look at the actual type, not at the declaration type. Okay? So the compiler will look at the kind of the object, which is the runtime, the actual type, and call the right method for us. Again, employee, we can cast the employee to the employee, person, object, or insurables. That is the typecasting to the interface. And here is the power of interface. You can see that the car and person and company, they are unrelated classes. There's the only common between them, they have only the superclass, which is the object. But the thing that the company, the car, and the person, they implement insurable interface. Now, the beauty of polymorphisms tell us that we can do typecasting of an employee or to the person, or doing an employee to insurable. We can do the company to insurable, car to insurable. Assume that this someone need to calculate how much amount of insurance policy for all the car, customers, company, and employee, and the managers. So we can create an array or a list or a collections of type insurable. See, the declaration type is insurable array. And we add inside this insurable array all the objects that are implement insurable interface. So now we can add car. So the typecasting will done automatically for us by the Java, because car implement insurable interface. Company implement insurable interface. We can insert it inside this array. Customers implement insurable interface. We can create a customer object and we can add it to this array. Employee and the managers. Then we create only one code that look inside this insurable items array and calculate and get the policy amount, because all these car, customers, company, employee, they have this method because they decide to implement insurable interface. That means they're going to implement get policy amount. So I can retain the policy amount from all these objects, okay, and I calculate the total policy amount. You see that the power of typecasting to the interface, okay? And you can see that during all the labs that you are working, you define, for example, if you want hash set, you create a hash set actual type, you assign it to a set. Set is an interface, okay? You create a hash map, okay? You assign it to a map, where map is an interface. You create an array list as an actual type. You assign it to a list as a type of interface. Because later on, you might change in your object array list to a linked list, okay? But still, you are working with an interface declaration type as a list, okay? You call the method. This is the kind of power of polymorphism and typecastings. Now, just to make, because this is a good question in the real life. When you go and try to build your Java applications, you're going to ask yourself, I should make insurable as an interface or make it as class, abstract class. Actually, there is no magic rules that will label all the objects. Oh, this is a PEST to P interface, or this is a PEST to P abstract class. It's based on the application that you try to build, based on your best practice, based on your experience, okay? That you will decide. But there is one thing here we can highlight. If we decide to make insurables as an abstract class, that means we're going to insert it inside the Java hierarchy. And we need to extend it. Yes, we don't need to create an object from insurable interface because they are abstract class. Yes, insurable interface we cannot also extend. But look at the hierarchy. These are the kind of hierarchy. If you want the hierarchy in the top, make it interface. If you want to be part of the Java hierarchy, make it on the one on the bottom, which is the make it abstract interface. Now, you force, when you make it inside the hierarchy, you force everything as is-are relations, okay? Again, there's a big question about this. I need it to be part of the inheritance, or I need it to be a separate. A car now is an object of insurable if I use the button, okay? But company and the car and the one on the top, they are independent, but both are implemented insurable interface. Now, good practice, whenever you are using the inheritance, you have the superclass and you have subclass. Try to reduce accessing the direct field. You try to create get method, set method, public method to access the fields, okay? Now, there is one thing that most of the students, they got confused about. Whenever we are discussing polymorphisms, we introduce the topic of late binding dynamic dispatch. And we don't need to confuse ourselves with what we call static methods. So the late binding is not working with the static methods, is not working with the private fields, is not working with the final methods even. So you can have a private field, private method. There is no late binding. There is no late binding with these privates, okay? Now, you don't have a late, you can have final fields, final method. There is no late binding with final method because when you define a final method, no one can override this method, okay? Because it's a final. It's defined inside the superclass, so the subclass cannot override it. If you define a static method, that means there is only one copy of this method for all the objects, for all the subclass, for all the superclass. So there is no point of late binding in this scenario. So this method cannot be overridden, and so we can only have one version of it. So whenever if you define a final get name, okay, so get name is defined final inside the person. So even the employee cannot override it. If you define get name as a static, there is only one copy of this method, okay? It's already associated with the name of the class. You don't need even to create an object to get a name, which is something weird, okay? Now, this is a question. I would like you to take half a minute, maybe even less than this. So after we discussed all this kind of inheritance, which is the best answer? E, A, D, which one? Did we have agree about one choice? All of you, do you agree about one choice? Which? C. Did anyone see other than this? D? It's actually C. Okay? The advantage of using, or the primary reason for using inheritance is to reuse the existing code. Okay? Not to ensure precondition of the method are met, not to hide any implementations. Okay? This is not the purpose of or a reason to use the inheritance. Okay? Not to duplicate any codes, because we use the inheritance to reduce and reuse the existing code. Now we close the polymorphisms and we start the design by contract and inheritance. And we need to see the impact of using inheritance on preconditions, postconditions. Okay? We have some preconditions, postconditions, and we need to see the impact of inheritance on these conditions. So the design by contract, the one fact you need to keep it in your mind while we are discussing this topic, if you have a subclass, the subclass at any point in your application should substitute the superclass. And if the superclass do something, the subclass should do the same thing. Okay? Otherwise, the client will be not happy. I'm not saying your application is broken or you have a bad design. Maybe you have a bad design or you have some kind of broken rules inside your application, but this is the general rules. If you are doing inheritance, the subclass should replace or the superclass and provide an implementation for the abstract. And that is also the polymorphisms. The polymorphisms say the dynamic binding. So with the inheritance, this is a very powerful tool, as we saw in the previous slide. We can create only one method, okay? And then we call the right method based on the actual type of the objects. How the design by contract concept extended to handle such kind of the powerful things by introducing the inheritance. Preconditions. Just to remind you, if we have a precondition about any method, it's a condition about the arguments. And we say this argument should be true before we proceed in, before we start execute the method. The condition is about the argument. Okay? Good? Now, class, subclass is supposed to be able to do everything the superclass can do. That is the inheritance. Okay? How they interact. So, the subclass can change the preconditions on a method. But whenever the argument is valid for the superclass, so the subclass should accept the same argument. So if the argument is acceptable by the superclass, the subclass should accept the same argument. Otherwise, we have to do a lot of work to handle this. So if we have superclass accept some certain arguments, the superclass accepts some certain argument, the subclass should accept the same argument. Otherwise, we'll not be able to substitute. Here is the client, and the client was aware that we have a class A and we have some method. Then we create a class B that is subclass from A, and we have override the same method. Now, if the precondition of a class P dot some method is stronger than the precondition of the class A some method, then this no fair for the client. Why? Maybe the client was aware of a class A at that time. So he created the code based on we have some method inside the class A. Now we are using class P. So whenever that trying to use a class P in a place where is a class A is defined, we will have a problem because the precondition is more strong. This sentence maybe is not clear, but We will see some examples later on. So you can, the problem here is make more strong preconditions, restrict the preconditions, trying to restrict the precondition. Here an example, we have a person, employee, and a manager. This is the hierarchy. So we could have one of these 4 preconditions. Which one is the easiest one? Which one is the strongest one from your point? Number 1 is the strongest one, or number 4 is the strongest one? 4 is the strongest one. So we can have any one of these preconditions. We can say we're going to set hourly pay for an employee, and in this case, we can say the employee has no preconditions. That is, the week can be any time. You pay $15 or $20, $100 million for the hour. There's no restrictions. We can have a second restrictions, and always the greater than 10. So if you try to assign $5 per hour, rejected. If you try to assign negative, you rejected. But you have to assign any number that is greater than or equal to 10. You can have more restricted constraint. You say greater than or equal to 10 and less than 20. So it's a little bit more stronger. But the most strongest one is a specific one. You say only $15 is acceptable. Okay? Otherwise, we're going to reject. So this is the strong conditions based on that. So this is one of the main facts. The subclass can change the precondition, but it must not strong or restrict the preconditions. So how we can see this in the example? Let's say this code is written inside the employee. So we have the employee, set hourly pay for the employee. We have no conditions. You can give whatever you like. You can give a negative value for the employee for hourly pay. Now, the manager decide to override and say the hourly pay should be greater than 10 and less than or equal to 20. Such kind of thing is not, I'm not saying is not valid, or you are going to receive a syntax error, or you will have a problem, or you have a Java will not compile, Java will not run. But we're trying now to discuss when you go to the real life and you try to create an application for the Java, you try to avoid this. You try to not see such kind of thing. If you have a superclass and the method inside superclass has no conditions, no limit for the hourly pay inside the employee. If you create an object of the managers, don't try to make more restrict on the preconditions, because at one time the manager object will replace the employee due to polymorphisms or typecastings. Okay? So imagine you try on the client side, you have the employee. This code will fail actually. So you create a declaration type P1 as an employee as a declaration type. You create an actual type of the object of a managers. Now imagine that you call this method. The client call this method and try to set P1.set hourly pay is 0. Now if we are handling the employee, there is no condition. You can put 0, you can put -1, -10, whatever you like. But if you are handling the actual type of the manager, okay, you cannot set any value. You have to give me the value between 10 and 20. Now look at the parameter here inside set salary. It's an argument of type employee. This code will fail. This code will fail. We have to do a lot of work to make this code is working. Okay? We have to do some pre-checking that we are handling the manager's actual type. Okay? So we are saying that polymorphism is not working with us. We don't use this advantage from the Java. So must not be able to do, so all the subclass must be able to do everything and sister classes can do. So if the employee, we can set 0 as our relay, the manager should do this. That's related to the preconditions. What about the postconditions? The postcondition is a promise from the method. After the method is finished, this should be true when I return to the client. The method might promise something about the state of the object, okay, when this method is called, and or might promise about something about one of its parameters. Okay? All these are preconditions. how the postcondition work with the inheritance, interact with the inheritance. The subclass can change the postconditions. If you have a superclass and subclass, the subclass can change the postconditions of the methods. Okay. Now, but remember, if the superclass promise something, okay, the subclass should promise at least the same thing. Okay. Here is the example. We have a postconditions for the class p.sum methods is a weaker than the postconditions for a class a.something. This is not fair. So you are read the API for some method inside the class A and promise you something. Now you extend it to P and you find that the promise is weaker. This is not fair for the client. Okay? So since the client might be not know about class P that has a stronger guarantee about, he rely on the class A about the strong guarantee on the postconditions. So restricting the postconditions. Let us see this example. Which one is strong? Which one is the weak? You can have one of these postcondition. You go to the method calculate the monthly salary. You can say there's no postconditions, which is the weakest thing. Yes? Or the strongest thing? No conditions. No postcondition. Is the weakest or strongest? The weakest. Yeah, retained value. The postcondition is about the retained value. The promise after this method is finished. This is the weakest postconditions. No postconditions, okay, is the weakest one. Or you can make a conditions that if I calculate the monthly payment for this employee or for this managers, I need the monthly payment should be greater than 500. Or you can say any monthly payment should be between 500 and 1,000. Okay? Or you can say very strong postconditions. Any monthly payment should be equal to 750 for all the employees. Now, if you have a subclass, okay, can change the postcondition of the method, but it must not weaken the postconditions. So let's say this is a method written inside the employee class, which is the calculate the monthly payment for the employee. And we have a postconditions. What is the postcondition is? Retain between 500 and 1,000. So the employee, when I calculate the monthly payment for the employee object, should be between 500 and 1,000. Now, if I extend the employee to clear the managers and overwrite the calculate the monthly payment inside the manager, and I said the postcondition for this method is guaranteed that is greater than 500. I weaken the postcondition or I make it more strong. I make it more weak. That is not good practice. Okay? In this case, this is not good practice. The manager has no upper limit on the monthly pay, while the employee has the upper limit for the monthly pay, which is 1,000. So the code is written for employee can now fail when it's given a managers. For example, if you try to calculate monthly payment for all the employee, so you try to create one method and you try to use the polymorphisms example, and you see the send an employee as an object, you calculate the monthly pay, and then you have some kind of notice if this employee is busy, or you need to shift some load from this employee, or you need to give some more hours. You calculate the monthly payment based on the hour that the employee is working, and you find if the value is less than 600, you say this is not busy, need more hour. Okay? If the value is less than 800, this is fair. No need to give him extra working task or something. And if the monthly pay was less than 500, you say this is a busy. Understand this? Code will not work if we send a managers, because the manager will have no limit on the upper bound. Now, just to put everything in one slide, imagine that you have a class A, and inside this class A we have a sum method, and we have some class invariant, some conditions about class invariant, which is the condition about the state of this class that always should be true. And we have some method, and inside it we have a preconditions, and we have some procedure to do, and we have to ensure some postconditions. So we require a preconditions, we're going to do some procedure inside this method, and we have to ensure the postcondition. This method is inside the class A. Now you define a new class, class P, which is inherited from class A. Again, you override the same method. But again, you have invariant new class invariant. So you have some conditions about the state of the class P, which is a class invariant. Always this class should have this condition true. Okay? And then you'll have the same method overrided. You define a new conditions, you do some procedure, and you define the postconditions. Now, to make sure, the precondition for the method inside P should always be the new preconditions or the precondition of RAM A. So the precondition, because if you have a precondition inside the method inside A, this precondition should pass a precondition inside method of P. That's why we have OR. Postcondition, we have AND. If we promise something from class A, the same promise should be valid also for the class P. Both. That's why we have to have used AND. So the new postconditions and the new postcondition, the original postcondition from A. If you have a class invariant, you will have to use AND, because if the state for a superclass should be the same as state of subclass. I can say you can have a class, okay, so of a student. So what is the class invariant for this? Is GPA of a student should be greater than 0. Now you create a class. It's, let's say, a class for a students who need to graduate, and let's say 4th year student. But to be able to be 4-year students, you have to have the GPA is greater than 3.2, for example. Now, the class invariant for a student is a GPA is greater than 0. The class invariant for the 4th year students should be also greater than 0, but we add more class invariant, GPA should be greater than 3.2. Okay? Such kind of thing we should maintain inside our Java applications. Okay? Now, if we are discussing a preconditions, okay? Preconditions, if it's valid for class A or valid for class P. But the postcondition should have the same thing, AND. So the postcondition for A and postcondition for P. Any question? If you want to leave the method is not defined inside the superclass, that means this is an abstract method. So just you put the header of the method and put semicolons, and then you rely on the subclass to override this method and give you the detailed implementation of it. Okay? Now we are talking about a method that is implemented inside the superclass, and the method is actually also implemented inside the subclass. So you have two implementations. In these two implementations, you have preconditions, postconditions, and how these preconditions, postconditions are related to each other. Okay? Now we will look at the static features. Okay? The static features is, what I mean by that, static fields. Okay? and the relation of these static fields when you define them inside the superclass, and then you extend the superclass to create a subclass, and how you can look at the static fields. So the static fields regarding the access modifiers, public, protected, private, work the same as non-static field. So the public and protected static fields are inherited by the subclass. The subclass can access these static fields directly, but the private static fields, it's not inherited. So we cannot access the private static fields unless if the method provides us with a public get method, okay, or a set method. The important thing is to remember that whenever you define a static field, you actually have one copy of this static field shared among all the classes and all subclasses. Okay? So consider the example that you try to count the number of employee, okay? The number of employee that you create inside your applications, okay? So you say I will have a public class employee, I create a static field, protected static field, number of created. So the name of the field is number of created, the type of it is protected, integers and static. So there's only one copy of this one. Then inside the employee constructors, I access this static field, okay, and increment it. Whenever I create an instance of the employee, I increment that static field. Now I provide a public method, okay, and type of it is static, because to access the static field, you have to provide a static method. Only a static method can access the static fields. So get number created will retain employee.created. You can see here, because it's a static, is associated with the name of the class. I don't need to create an object for it. And there is only one copy of it, number of created. Now we have some other method. We'll just focus on this part of the definition of the employee. So the type is protected, not private. So all the subclasses can access this directly by the name. Let's say we extend the employee to create a class of managers. Now inside the manager constructors, we call the superclass, which is the first line of the constructors. And also we ask manager.number created. We don't have any static fields inside the manager. Now number created is a static field inside employee, which is the superclass of the managers, and it's defined as a protected. So the manager extend the employee, they can access all the managers, they can access this static fields, and there's only one copy of it. So managers, we use managers.number created. Remember, we use manager.number created. I'm going to look inside the managers. Do I have any static field called number created inside the managers? No. Then the Java will look inside the superclass, the employee. Yes, we have number created as a static inside the employee. We're going to increment it. So we say that's done. We define, we can create, we count the number of employee. Okay? Remember that there is only one copy of this static field for among all the declared classes and subclasses. So someone now create a main method, and inside this main method say a new managers, and print manager.getNumber created. Now getNumber created is a static method. It's not defined inside the manager. It's defined inside the employee. So the compiler will look inside the manager. Is there any getNumber created? No. It will look inside the employee. Yes. And you can see here is not using M1 dot, because this is a static method. We can use the name of the class. So we use manager dot. Do you think will retain, or this code will print 1 or 2 based on the previous slide? This is the previous slide, if you want. So this is the employee. Static field is number created. If we call employee constructors, we're going to increment. If we call a manager's constructor, we're going to increment. So now someone create this code. Do you think this is good? How many employees created? It will represent 2. This is wrong. Even we create only 1 manager, we don't create any employee, we're going to have 2. Why? Because we have only 1 copy of the static fields. And when we call the employee, we declare the static field. Employee increment the counters whenever time is called, and this static field is inherited inside the managers, and there is only single copy. Manager constructors called the superclass constructor. You remember super as a first line. We call the employee constructor. We increment the employee, and also the manager increment the counters. So the managers end up increment the counter twice. When it's called the static field to increment the constructor of the employee, we get increment the static field, and also explicitly we increment the counters. Okay. If you would like to count the employee and the managers, maybe one decided to create 2 different or 2 separate static fields. So we can have a count number of created inside the managers and number of created inside the employee. Both have the same name. It's work? Yeah, it's work, no problem. Okay? But we will have something here. We have a managers, extend the employee, and we create a private now. Private static integer number created. The name of the static fields is identical to the name of the static field inside the employee. Okay? Now we say super number of created. Now what I want to do inside this is I need to count the manager separately. I need to count the employee separately. So here we will increment the employee dot number created. Here we increment what? The manager dot created. Okay? By doing this and having the same field or even the same method, static method or a static field inside the managers and inside the employee, they have the same name, we say we have a phenomena of hiding the fields. Now, the managers can see only the number of created, that's a private, is created inside it. The number of created inside the superclass is hidden. Whenever I use manager dot number of created, I'm going to call the manager number created. I will never reach the number of created of the employee unless if explicitly I'm saying the employee dot number of created. Okay? So the superclass, you may only have that subfield hidden from the superclass field. That's what I said. So this is considered a bad style of coding. It's better to have 2 static fields with different name. So you have number of created for employee or number manager created, number of employee created. So if whenever you decide to have the same name of the field and these fields are static, try to use different name. Okay? Because you will have the hiding the fields. And this happens whenever you have a static fields, the same name between the superclass and the subclass. After we discussed the static fields and the effect of the static fields with the inheritance, and we saw that the static fields has only 1 copy for all the superclass and the subclass. Now we will discuss the static methods. We define a static method to access the static field. There is no significant difference between the static method and non-static method in terms of the access modifiers. So if you define public methods or private method or protected method, they have the same thing. So public and protected will be inherited. Private will not be inherited. Now, but there is a one thing that we have to always keep in mind. Dynamic dispatch or late binding is not good or is not working with the static methods. Okay? Because static binding, we will have a static binding at the compile time. At the compile time, we do the binding between the objects and the methods. Okay? We don't need to have the dynamic binding or dynamic dispatch or late binding. So, sorry. So the static binding, which is the binding at the compile time, okay, not at the runtime. So the subclass can hide the static methods inside the superclass by declaring the same static methods. So the static methods with the same name, the same signature, okay, of the superclass, okay, that means you hide it. The same thing we did with the static fields. Remember that whenever you write the static method inside the subclass, you cannot access the parent class using super, because super, that means you are referring to the object, and you cannot use this inside the static methods. Will give you a syntax error. So static methods can access only static fields, and you cannot use this or super inside the static methods. This is an example. You have a class called person, and inside this class we will have public static void test class method, and inside it we have print static method in the person class. And then we extend the person by creating a class called employee, and inside this employee we have public static void, and we give the same name test class method. So we print different message. We print the static method inside employee class. Now both static methods have the same signatures inside the subclass and superclass. If we run this, we define employee E1, we create an object, so the declaration type employee, the actual type is employee. Now we say E dot test class method, and you can see here test class method is a static method. We call it using the object. Okay. Now we define P1 of a declaration type of a person, and we assign E1. P1 dot test class method. This code will compile or will not compile. When you remove the headset, you can have a question. So the question is again, this code will compile or will not compile? Will compile. There's no problem with the compilation. So what's the result? What we're going to print? Test class method. Which one we're going to call? The first one, E dot test class method. We're going to call the employee or the person? Employee. The second one, employee. Remember, the polymorphisms is not work with static. So the first one, the binding, the static method are bind at the compilation time, not at runtime. So we're not going to look at the actual type of P1. P1 is the declaration type is a person. We're not going to look at the actual type of P1. The actual type of P1 is employee. With the static, this is not working. Okay? So we'll have static method at the employee and static method at the person. When I call P1, the static binding at the compilation time. Okay? Not at runtime. If I don't have a static method, the polymorphism will work, and I'm going to look at the actual type. But here, because we are working with the static, the binding between the person and the static method done at the compile time. When I say P dot test class method, I will look at the declaration type. What the declaration type is person. I'm going to call the static method of the person class. Okay? E1, What is the static method? I'm going to look at the declaration type, employee. So I'm going to call the static method of the employee. So the dynamic or late binding is not work with the static method. Okay. So again, I'm highlighting this because many of the students got confused about late bindings with a static method. There's no late binding for a static methods. Everything is done at the compilation time. Just to remind you again, private methods, private fields, final method, final fields, static methods, there's no late binding with these. Okay? If you have a private fields or private method, there's no late binding. Static method, static fields, there's no late binding with these methods. Now, we discuss what I mean by static method, static fields. Any question? The same thing. One is the explicit typecasting. You explicitly inside your code, you put curly brackets and you give the name of the class. Or sometimes if you do the equal, that you will rely on Java to do the automatic casting for you. And if this casting is not valid, for both cases you will receive an exception. If this casting is valid, the compiler will run and you can use the polymorphisms. Now, there's two methods that are provided by Java, that is getClass and instanceof. And we discussed these two on the early in this course. When we design equal, when you create your object, you want to design the equal methods, and you will say, I want to use getClass or instanceof. getClass is better than instanceof if you want to use the method. Let me just explain to you why. Instanceof is an operator. It will check the object. Is if the object, the given object, is actually a type of the second argument. So object, that is the syntax. Object, instanceof, you give a class name. So it will return it true if the object is a type of the class name, otherwise will return false. Also, it will return true if the object is a type of any descent, okay, of any child of or a subclass from this class name. So if you have the object that is subclass or a child from this parent class, it will return true. So just to test your knowledge, based on the declaration that we gave in the previous slide, we declare object, person, person P1, person P2, and employee, E. And then we create the actual type for them. So O is a declaration type is object, but the actual type is a person. Now, if I call this method, I will check O is an instance of object. What I should receive? True. Because the object is a parent and person, okay? So it will receive true. If O is an instance of person, true. The actual type is person. Is O is an instance of employee? False. Because its actual type is a person, okay? And we cannot go, so we'll have false. Now, P is an instance of person. True. P is an instance of employee. False. P1 is an instance of person. P1, true. B1 is an instance of employee. True. P1 is an instance of managers. False. Now P2, an instance of object. It's an object. P2 is an instance of managers. True. Now E, which is actually has a managers as an actual type, is an instance of object. manager, person. Manager is a subclass of employee. Employee is a subclass of person. Okay? So this is how the instance of is working. It's checking if this object is a type or actually any child type from this superclass. So the superclass is person. Is E is a type from the superclass person or any subclass from person? Yes, because the manager is a subclass from person. Now let us look at about getClass. getClass, it's a final method. No one can override it. And what is the behavior of it? It's retain the name of the class that is used when you are using new to create. And you can use equal and not equal operator to make sure if these two objects are created from the same class or not. So new employee, when I say get class, I will retain what is the class name is used when I use the new operators. So here, an example. The same thing, O, P, P1, P2, and E. Now, O, new person. When I say O dot get class, what should I see? Person. P dot get class, person. P1 dot get class. Be careful. Get class will retain the class name that used with a new operator. What is for P1? The declaration type is person. A new employee. So I use employee class. So when I use P1 dot get class, I will have employee. P2, I will have the managers, and E1 will have the managers. And if I answer, you can see even I have the name of the package. The name, the package, the person. P1 will have the employee. Okay? Did you see the difference between instance of and get class? Okay. So when you are trying to use instance of with equal method is not good, because it will give you all true for all the superclass and all subtype or subclasses from the superclass. But when the get class will give you the actual class that is used when you are using new operators. Here is, for example, if you create a class employee and you derive from person, so the person is a superclass, and then you have the hourly employee, which is a derived from employee. So you have the hierarchy like this: employee, person, employee, and hourly employee. Okay? And you can say that the employees are equal if they have the same name and the hire date. So this is a bad implementation. You say, if I want to say other object, instance of employee, then this will return false if this is other object is not an instance of employee. Now, if you create in your class employee E1 and use a new employee, okay, so the declaration type for E is an employee, the actual type is employee, and H is actually has a declaration type hourly employee, and the actual type is hourly employee. Now, if I use Boolean test H, which is E dot equals, I give H. And then Boolean test E, H dot equal E. Which one true, which one is false? Or both are false, both are true. Now, E dot, that means I'm calling from employee, and I send H as another object. So I will call other object instance of employee. H is an instance of employee. H is what? Hourly employee, which is a subclass of employee. This will return true. Then I will have test H as a true, because I'm calling E dot equals H. What is the other object in this case? Is H. What is H? Is actually the hourly employee. So test H will have a true. What about test E? Now I'm calling H dot equals, and I send E as other object. Then I will ask, is actually H is a subclass from employee. If you want to say H instance of employee, yes. Yes, because I'm calling that other object. What is the other object? Is H. H is an instance of employee. Hourly employee is an instance of employee. That will return true. If it's not true, this will return false. So the first one will return true, the second one will return false. Okay? The best way to do the equal is to use getClass. So whenever I say that two classes are equal or two objects are equal, I will look at the type of the class that I use when I use a new operators. So a new operators. Okay? Now this is the better equals method inside the employee. I say getClass. If it's not equal, other.getClass, I will return false. So for E, I use employee. For H, I use hourly employee. So I will return false because these are two different objects. And based on my criteria, both employee are equal if they have the same name and the same hours, or the same hiring date. So in terms of which is the better, so getClass will retain more exact, okay, about the type of the class. An instance of is a simply operator that tell you if this class is an instance of this object is an instance of this class or any subclass of it, okay. And with the getClass, you can retain a string or retain a type that you can use equal or not equal to compare between them. Remember, there is two things before we close the inheritance topic, is hiding versus overriding. Don't get confused. We need inheritance to do overriding. We need to have the method is defined inside superclass with some assertion of behavior. We need to override it inside the superclass, in subclass. But hiding is totally different. Hiding, the concept of hiding is different. The hiding is what we discuss about hiding of the static fields and static methods, okay? And encapsulation, yes, is hiding, is making the fields private and only accessing the field using get method and set method. But here is, we discuss about hiding for static methods and overriding, which is override the method inside the subclass, okay, to provide extended behavior. We don't encourage hiding the method, we encourage overriding, okay? Good. So we close and we will continue next week. We'll start a new topic, which is the computational complexity. And after we finish the computational complexity, we're going to start the recursion, okay?